Testing, testing, my check. Good evening, everybody. How are we doing this evening? Say good day, good morning, and good evening, depending on where you are at in the world. How's everyone doing today? Hey, Kenneth 3D Prince. Thank you for the birthday wishes. Yeah, for those of you that are just joining, it is my birthday today. I'm a young 51 years old today. I'm just glad to have been through another year and hopefully got many more ahead. So what are you doing today, Kenneth? You doing anything fun? So we're gonna just be having a chat and chill stream tonight. I just got a text right before I went live that my two boys are on just got on the plane and they're flying in. So I'll be getting off in a couple hours to go to the airport and pick them up and start a fun weekend. I'm gonna take a long weekend and enjoy some family time. Okay, so is that the Micro Swiss NG, and what printer are you installing that on? Yeah, the Micro Swiss NG. So I haven't worked with the Micro Swiss NG extruder yet. I've got a few Sherpa Minis. I got a Sherpa Mini on my Ender 3, and hey, Buddha 3D, thank you for the birthday wishes. Okay, so you have one that's an Ender 3 Pro and one that's an Ender 3 Pro full linear rails. So by full linear rails, you mean both are all X, Y, and Z? Because right now my Ender 3 sitting back here, I've got linear rails on the Y and the X axis. I've got rails on stock that I can go full, and I'm debating whether to just go linear rails with it and keep it that way, or switch it over and do another switchwire build. Because, well, why not? So how are you doing today, Buddha? Are you working on anything? Yeah, well, I mean, basically the Ender wire, which is the one that I have right here, is Ender 3 Pro conversion, and this is Red Dragon. And then the one that we just finished building, which is right here, is Blue Dragon. And yeah, they both started out as Ender 3 Pros. Hey, Pete Salas, how are you today? Okay, you went purple gray for an Ender wire. And is that based on an Ender 3 Pro, an Ender 3 V2, or a standard Ender 3, Buddha? I'm doing pretty good, Pete. I went ahead and worked today because uh, Friday is going to be a slow day anyhow, and I just got a text from my boys. They just got on the plane heading this way, so we'll be leaving tonight to go pick them up, and we'll have them out here for a couple of days, or till Wednesday. So I'm going to take Monday and Tuesday off work as well. So we'll have 4 days off just to hang and chill and go around and do some things. Okay, you got a $99 Ender 3 Pro from Micro Center. Okay, cool. Yeah, my closest Micro Center is Fairfax, Virginia, which is about a 6-hour one-way trip. Um, so, hey, thanks for the follow, DFranks89. And with that, we just hit our follower goal of 100 followers for the channel. Thank you so much for doing that. That is great. As always, follows are free, and subscribes and bits are always welcome, but never required. So thank you very much for coming out and joining me this evening on my birthday stream. But yeah, it's probably a good thing that Micro Center's like a 6-hour one-way trip, because otherwise I'd be there all the time. As it is, I got this. This is a used Ender 3 Pro. I've been buying them on eBay through one of the sellers on eBay, and it's not that expensive. It's actually fairly cheap, and you know they both worked great for the builds that I've done. I've gotten 3 of them now. The first one I got it built, put back together, made sure it was working all right, and then gave it to my buddy. And then, of course, I built Red Dragon, and now I've got Blue Dragon here. Yeah, so initially what I was looking for was just you would have to get the 40/40 extrusion for both the Y rail as well as the base cross member, because either that or you're going to have to modify the existing base cross member on the Ender 3 standard to make it slotted for the 40/40 and the particular holes that you'll need for those. And because you're basically going to straddle an existing hole with 2 more holes, didn't know if that would become a weak point. And when I started looking, there was one place that I could find the Y rail, but I couldn't find the base member. And there was one place on eBay, there was one guy selling the Y extrusion and the base cross extrusion, and they wanted like 90 bucks plus shipping. I was like, well, hell, if I'm going to pay 70, 80 bucks, I might as well just get the whole thing. And I probably got 15 or 16 motors sitting over on the bench that are spares that I'll use for doing a Rook build or some other build down the way. Yeah, exactly, Pete. I mean, when you can go to Micro Center and pick up an entire printer for 90 bucks new in box or 100 bucks new in box, I'm not going to pay you $90 just for the rail itself. Exactly. At that point, I would just buy a a meter 40/40 extrusion and build it myself. Hey, Ozzy, how are you doing? Well, I'm guesstimating about 16 motors. I might actually have more. And like I said, they're a smattering of a lot of Creality motors from pulling apart different builds. The my Ender 5 Plus, which is downstairs, has been fully converted to a 0G Mercury 1, or actually a 1.1. So it's using it's a Core XY now, using the EVA 2.4 tool head with a Dragon high flow and an Orbiter V2 extruder. And I've also just converted it to the Hydra kinematic bed, so it's the triple lead screw with the kinematic bed. So I've got the full Z-axis from that, and I don't know if I'm just going to use the Z motors and the lead screws and turn my D-bot into a triple lead screw, or just go with a full rebuild and full customization, because I'm thinking the D-bot, which is a 300 cube build, I think I'm going to switch that out to the 0G Core XY setup, just because I like it better, and I won't have to do anything else other than maybe replace the cross member extrusion, and I can reuse all the other bits and bobs that are on it. So I can do that with very little ease. Oh yeah. I mean, it's one of those things that my bench stock, you'll see that there's a 4-foot table right here that I just moved over here. It used to be in this corner. I got like I guess a 40-inch table here. That way it doesn't obstruct the access into the closet, which is my filament closet. And so that's got motors and bends and all my screws. And eventually this stuff's going to get cleared off and stored properly in some Gridfinity gear over here. And pretty soon we will be breaking out the Mars 2 Pro and putting it on this table. Yes, I know it'll be right in front of the window. I can put something up to block the window. But I'm going to try and get it set up right there. Probably one of the next things I do on stream. The links for the rails on which bottom, Pete Salvis? Hey Chewy, how's it going? Thanks for the birthday wishes. And Westery, how are you, sis? How are you doing? Thank you for coming in and joining us this evening. By the way, folks, I still do have the lag on. I can probably try and drop it down or take it off completely now. I'm getting a little bit better up and download speeds, and my bit rate seems to be staying pretty constant. So we might work on getting some of the lag taken out. Hey, Darth Gollum, how's it going? Thank you for the follow, Seth Gioli. I hope I'm not butchering that too bad. The bottom of the underwire, the two side rails that are the feet and the cross beam. Okay, yeah. So, um, yes. So in essence, the the base frame goes all the way to the back, and then we add the extensions to the front to give us the full deck. Here, let me. Am I here? Horrible. Where did the other one? Ah, I don't know why that one got moved up so high. Okay, so the printer itself, the extrusions still stay right at the back grill, and then we add this extension right here. So the full length, if you wanted to go get new 4040s, it winds up being right at 18 inches. So whatever 18 inches is in millimeters. Unfortunately, oh wait. Yeah, I should be able to get you that in millimeters, hopefully. Looks like it will probably be about 400 and right around 458 millimeters. Yeah, there you go, about 457.2. So I would just say 458. Yeah, so if you're going to do a conversion of a standard Ender 3, just remember that the, the base on all of them are the same. I mean, you can get the extended rails on the side. You're just going to have to use this as a template and drill your 4 holes on each side and make sure that you counterbore so you can get the heads to fully seat in. The big thing is on the middle brace, because it's the same size, regardless of whether it's the 2040 or the 4040Y extrusion. You're just going to have to get your 4040 and figure out where you need to cut, because remember, it's inset in that center base section. And that's the piece, like, I would, if I could find it, I would love it. I would love it if we could just contact Creality and say, hey, can I get, an Ender 3 Pro center base extrusion, right? Or if we could just order the actual extrusion from them, that would make so much easier, because then we could take, a standard Ender 3 and do the conversion and not have a problem. But I want to say with the conversion that I've seen for the generic, the OG Ender 3, it called for buying the rails, and in that it does give you what rail size to buy and or have cut. So I mean, if you want, I don't see why you can't. When really, when you do this, it's just going to be a matter of how do you mount your extruder. Then you're going to have to come up with a custom mount for that. For using the NG extruder, Kenneth, because most of the Ender rail mounts, well, yeah, you're still going to have to come up with a mount, because if you're going to go to the Ender wire and using the XZ like this, it's going to be more difficult. If you still want to use your NG extruder, I would suggest going with a belted Z mod where you get rid of your Z lead screw and you can run belts on both sides, which will help with the sagging of the gantry on the one side, especially if you're going to a direct drive extruder. So I would go with just a belted Z setup, and you can get it where I would go and get a Ender 5 Y motor, because the Ender 5 Y axis has the motor that has the whatchamacallit, I'll say stems for lack of a better term, on each side of the motor. And then you can just do the extension rods that way. And that way you can drive single motor, but you can drive both belts, Z belts off of one. Yeah, it's a dual shaft motor, Chewy. Like words couldn't come to me. 300 millimeter linear rail. For an inner wire conversion, all of the rails that I've used here are 300 millimeter. Oh, 250 millimeters for the center base extrusion. That's probably about accurate. Because remember, it sits between the two 40/40 extrusions. So altogether, that, I mean, if it's 250 plus 80, you're looking at, God, perfect math, 330 side to side. Yeah, I'm coming up with about 325 millimeters side to side. I mean, I had to flip it over to get you an accurate one, and right now I've got it powered up, so I guess I can, yeah, let me go ahead and try and lay this over gently. Yeah, it's 250. Okay, Kenneth, you were looking for the exoslide kit? Yeah, in that case, rather than trying to do it as an ender wire, because the big thing with the ender wire is you're doing a core XZ, so it's the belt pass and where the belts mount underneath, because you've got two of them versus just the one. And that's where I'm thinking you might have to build a specific plate or an extension under the bottom in order to mount on like a standard Ender 3 plate, because you can get plates for an Ender 3 for a front mount extrusion like we've got on the Ender wire here. You can get plates for a front mount, but in order to do that, you're still going to have an issue with the belt pass, and that's why, because you got two different belts versus just one. How did you get around the bearing belt tensioner? In what regard, Chewy? Oh, there's an AliExpress link out there? I may have to fly it up over there and check it out. Let's see if I can bring that up. Of course. Doesn't like that. Okay, so yeah, I'd have to play with the browser source on that, unfortunately. Yeah, let me see what that is. So it's $60, free shipping. And quite honestly, the pictures look like it's used. But I mean, it's $60 and you just get the two frame rails. You could probably get those frame rails cheaper. You're just going to have to do some cutting and machining on it. You might even be able to get, whoever you get the rails from to do that for you if you know the specs. Okay, so like on my Ender 3 back here, I've got my rail mounted on the top. There's a kit that you can get. It's basically two L brackets, and they mount to the back of the extrusion, and then the rail mounts on top of it. And with that, it enables you, and that kit comes with a plate that basically goes over the top of your front plate. So when you take the wheels off, you'll sandwich those two pieces together and mount it. And so your carriage is riding on that, sitting on that rail. And the nice thing about that is when you do it this way and mount it to the face, you could potentially lose range on your bed, and you wind up cutting a 220 bed into like 200. And that's why on most of the conversions you see you move the rail forward to the forward set of holes and then add a roll in or a hammerhead nut to do the back. Yeah, and that's the thing. On Comgrow or even Creality's site, you can get on Creality's site and they will have used printers or open box printers, and you can get those for $70-$80, and that includes shipping to you. So, excuse me just one second here, folks. I got to pause, so I'm going to mute myself real fast. Okay, sorry about that. Yeah, so, and I can try and find that rail kit again, and I can send that to you on Discord, Chewy. Like I said, I got it off Amazon, and probably get a good enough. Yeah. Oh yeah, there's definitely some good and some bad extrusions. Definitely. So on the interwire here, I did go through last night and finish the wiring job on this. Yeah, let me go ahead and shut it down. And I'm going to do it the right way and shut down the host, give it a couple of seconds. Yeah, I mean, there's different mounts that you can use, Chewy. I mean, and there's plenty. And I used to sit there and go, no, you don't really want to use a printed mount. And then I built a couple of Vorons, and I'm like, okay, if you print a printed mount, make sure you. I mean, I would whether you're going to do it in PETG, it's up to you. Um, I'm going with ABS for most of mine, at least anything on the extruder and carriage. And if you print it with the Voron specs, it's going to be plenty sturdy enough, so you won't have to worry about that. Sorry about that. Just got a text from my kids that they made it to boarding. So let me move these out of the way. And we'll flip her over here. Screens. And move you guys around just a bit. Okay. So on the last stream, yeah. Yeah, ABS, ASA, either one of those will work. I'm just saying as far as the perimeters and the amount of infill, stuff like that. And I also find set all of your widths to the size of your nozzle, whether that's 0.4 or 0.6. Ever since I started doing that, every single part that I have printed has gone together with zero issue. Every time I try and use a standard like Prusa Slicer profile, which on a 0.4 has 0.6 here, 0.2, 4.6, 4.2, 4.5 for different parts, I have issues. Thank you, Westery. Tell me I said thank you. She is so kind. Did you get her some vegan strips so that she could have her bacon? So we did have to do a little bit of troubleshooting on the last stream just to identify where to place everything. We knew based on the mounts that we had that the main power supply was going to go on this side, and really it's here or here. It cannot fit right here with the grills and stuff in place. So we had the main power supply here, and it's just too cramped back here. And with our fan here, I wanted to try and keep as much airflow as possible going down this channel. So we have our SKR Mini E3 V3 board here, and we went with the Raspberry Pi right in front of it with the Ethernet and USB connectors facing the back. And the nice thing is that enables us to just get our cable wrapped nicely, and our wireless or our Wi-Fi port or antenna is on this side of the board anyhow, so that puts it as close to the front of the machine as possible. You may also see this cable here with a dongle. What this is this is a USB male to female extender, and what that lets me do is extend a USB port through the front of the printer. And the nice thing about that is I've got a input shaper cable pre-made, and I'm getting ready to rather than using a pigtail where you have to put it on the right GPIO pins, I'm just going to go ahead and solder it to a Raspberry Pi Pico board, and then that will enable me just to plug it in USB right through the front, and I can mount it on the tool head, do my input shaping, and then that way it's really modular at that point, and I can take it to any of my printers. All I need to do is figure out, okay, where do I mount it, and do I have a mounting adapter to mount it to a particular tool head? Um, we're also using a DC to DC converter, which is this piece right here. So it takes 12 or 24 volts in and it gives 5 volts out. There's different ones of these on Amazon. I've seen 3 amp, 5 amp, and this one here is a 10 amp. So I've got plenty of juice. I shouldn't have any under voltage issues going to the Raspberry Pi. I did connect it directly to the GPIO pins for power and ground. And when I did that, I ran, so pins 1 and 2 are 5 volt in and 3 is ground. And normally you can run, they'll say run 1 and 3 or 2 and 3 to get power to the board. I actually ran both to 1 and 2 for 5 volt in and the single ground in. So I'm making sure I should never get an under voltage error on the Raspberry Pi. Okay, I do have heat sinks on the main chips there as well to try and suck off heat. And on Red Dragon here, which is running the Manta M4P with the CB1 module, with the big heat sink on the CB1 module, I'm getting readings of like low 30s during a print off of the Raspberry Pi module. Yeah, if that Pi is pulling 10 amps, yeah, it's cooked. But the nice thing is this also gives me a standard 5 volt power, so I don't need to try and provide 5 volt through the Pi for anything that I want to run. All I need to do is run basically the signal wire, and then I can control other LED lights. Yeah, so if I wanted to put a light bar on the front or back, or if I do an enclosure and I want to add lights in the enclosure, I can do that and run it off of here for the power and just run signaling either off the board or off the Pi. Yeah, that's the reason I got it. And it's like $1 or $2 difference between the 3, the 5, and the 10 amp. So I figured might as well get it. And I did also get one of the standard 5 volt power supplies like you would get for one of the other, like a Voron 2.4 or a Trident kit. And once again, if I had a standard Voron layout where I had a cross member at the front and a cross member at the back with a bigger area to work with, that makes sense. Make it rainbow vomit. Let's see. Yeah, no, not going to do that. Hey, Rob Ank, how's it doing? Thanks for coming on in, and thank you for the birthday wishes. I appreciate that. So yeah, we're just kind of going over it. I did go through. I could not find my really nice solder connectors, so I did crimp these for now for the bed. And I did do Wagos on the thermistor, just because late the other night my eyes and trying to solder those fine wires was not going to work. I did do the pull test and everything's tracking just fine right now. But yeah, everything is working. I have had this on the bench running for 2 days straight. This is the SKR board and the Raspberry Pi that I had in my Ender 5. So they're known good boards. They were good when I used them back there, so I'm confident that they'll work with no problems. So I've been happy with that. And I do have the bottom panel cut. So after this, I will come in. All you do is pop the 4 feet off, put it on there. The feet will go back in right through the 5mm holes, and there will be an M3 hole right at the front that goes into the heat sets on the front of the extension pieces. And so that's it. There's 4 M5s, 2 M3s, and your panel's back on, which right now running this, I'm getting mid 30s on the temp off of the, oh, sorry, ads. I'll give that for a second. Good chance for a hydration break. Five ads in a row. Oh no. What am I set at? Yeah, I think I'm set. I think I have it at the default, which is, oh, thank you, Chewy, for gifting Buddha a tier 1 gift sub. That is awesome. I appreciate it. That'll take care of the ad problems for you, Buddha. Yeah, I don't think I've changed any of the basic ad settings, so I think it's set for a minute and a half, twice an hour. It's something I probably need to go and take a look at and adjust some. I've only been streaming for about a month, so still trying to figure out all the switches and stuff. But once we get the bottom plate on here, once again, I cut my deck panels and my bottom plate on my Shapeoko 3 XL CNC. And so it's 4 M5 bolts, so the feet come off, and then these will go right back in with the feet going right through them. And then an M3 at 2 locations on the front. Yeah, not a problem, Buddha. Sorry about that. Like I said, I just kind of forgot about it. But I will put this on, and I'll probably see about another 5 to 7 degrees Celsius drop in the reported temperature on the Raspberry Pi board compared to what I'm seeing running it now versus what I'm getting on Red Dragon. So definitely, these 60-20 fans, even though it's just a single one, it's blowing right down this cavity, which is why I tried to get this as far over here as I could to keep that cavity nice and good and streamlined. But with that, I'll go ahead and set her back up and get her turned back on. And you might have saw on there as well, the 12864 board is the requires the EXP1 and 2 connectors. So I did get a breakout board that allows, basically it uses the EXP1 header and the SPI header on the SKR mini board and gives you those 2 lines that you need so that you get the full graphic display and all the NeoPixel lights and stuff on the display. So, and we're back up and running. The nice thing is too is, as you can see, the screen's all blue. I went ahead, because this is Blue Dragon, and changed the screen to straight blue. Thanks, Buddha. Yeah, we did have a few fits and starts on this one. One of the other things that I will show you and talk about, might be easier if I switch the screen view here. Okay, and then can I tilt this one just a tad bit? Probably gonna bite me, so sorry. Tilt. You can do it. There we go. Okay, so right here, we are not using a standard Clockwork or Clockwork 2 extruder. We're actually using a Bondtech LGX Lite extruder on here. And we have a 2-part toolhead board. So this board, it's exposed that you can see, has 8-pin header that sticks out. And then the toolhead board itself has an 8-pin connector, so the 2 fans and the LEDs terminate on a board that sits in this part of the shroud right behind the fan. I think this particular display is the Physetic, and the one that's on Red Dragon's the Big Tree Tech. But yeah, I love those displays. They're really good. They're really good. I do have a. Here, let me grab this one. So I do have a Big Tree Tech. This is the TFT 35 display. They also make this as a TFT 35 E3, I think is the moniker on it. And what it does is it moves the knob from here down, and it's a drop-in replacement for the Ender 3 line. And you have a couple of ways that you can configure it. You do have EXP1, 2, and 3. So you can do the 2-wire out, you can do the 1-wire out, and run it like a standard Marlin display. Or you can run it like I've got it configured here, where you've got the TFT panel, and you get your pretty backlights and the ability to do touchscreen with it. This is not Clipper screen compatible though. The TFT 35 is not Clipper screen compatible. So if you want to do Clipper screen, you need to go to the is it the Pi screen or the Pi TFT? The one that you can actually mount a Pi board right on the back of the display. And it's an HDMI display. But this one you will see also has SD card port, USB port, and there's a bunch of various other things that you can run directly off the display itself. Yeah, the Pi TFT. So this one's going to get mounted on the Mercury 0G downstairs, which is the Ender 5. So it's going to get mounted down there again here in the not too distant future. Because I really need a display. Right now I'm walking around and connecting to it with a with my iPad. Which, by the way, you know, a 10-inch iPad Pro does make a really good display for any printer you ever want. So yeah, good deal. So on your printer, so we just got a brand new printer. We just got it set up. We've done the smoke test. Right? We didn't release any magic smoke, which is always good. Hey, Royal Nami, how are you? Thank you for the happy birthday wishes. And yes, before anybody asks, I have a cookies and cream Oreo bundt cake. So I do have a birthday cake. And I didn't get any candles because, yeah, I don't want to burn anything down. This didn't start smoking, so I don't, you know, no smoke. No smoke's good. Yeah, you know, it would be, you know, the Clipper screen and the touch is all cool and everything, but quite honestly, all of these right here, even though they're sitting here, I have my setup, well, here. You'll kind of see. Sorry about the mess. So I've got a setup so the left monitor gets connected to my work computer on the left side, and then the right monitor, which is the big one, gets connected to my personal laptop, and that's kind of how I work. And so I can watch everybody stream some, you know, catch some streams, just listen to streams that I missed in the background while I'm working. But if I need to print something, I can also just kick off a print right from the browser and go. And I do have another monitor sitting down here that might actually get mounted up here as a dedicated for the stream computer rather than me having to keep going back and forth. But that's evolution stuff. Yeah, thanks, Cheria. It works kind of well, and that is a sit-stand desk, so I can raise and lower it as need be. but we got a printer set up. The first thing we do is smoke test. So I had it laid on its side, and I kind of stood to the side as well, because if anything blows off the board, I don't want to be standing in the way of it. Yeah. Too many years in the military. So I stood to the side, flipped the board on, all the pretty lights came on, no blue smoke. So we're good. We passed the smoke test. So then I get it set up right again, and we just start going through the Voron design documents page for the initial setup. Sorry. And you know, it's very, very easy things. The first thing you're going to do is bring up your browser, log into the interface, and you're going to start checking your end stops. So let me see if bear with me. I'm going to try and get my browser window working again. Hey, Frank and B Gaming, how are you doing? Thank you for the birthday wishes, and thank you for coming out and joining me. There we go. Yay, we got a screen. It's an AliExpress screen, so we will get out of that. Okay, so once again, the theme of the printer is Blue Dragon. So you'll notice that I do have the name set up over here, and I've already got the VS set for the serial number, because I will be doing a serial number vid for this later today. So first couple of things you want to do is, one, can I get logged into the interface, which we can. What was that? Frankie B? Your self burner keeps jamming on you. Okay, is it, so stealth burner, are you using CW2? And what hot end are you using? You're using a standard V6 and the CW2. Okay. And is it clogging in the nozzle, or is it jamming in the extruder? Okay. So one of the things that you want to try and do, I'm going through it and thinking. So between the extruder and the hot end, you've got a small length of PTFE2, right? Yes, subsector, it's Clipper. Be nice and thank you. Welcome into the stream, subsector. Would it be better if I had some type of Star Trek theme overlaying Clipper? I mean, that might be one way of getting you on Clipper, and I'm sure you could do that. It's just CSS files and images. Exactly. So there's a small length of PTFE tubing, and we wound up doing the same thing on this one. On that tubing, get yourself a it would be a deburring or a countersink tool. Where's mine at? Give me 1 second and I will grab mine. Looks like an oversized drill bit. And I have no idea where mine went to, but oh, there it is. Here we go. Let me switch screens again. Okay, so you have a small length of PTFE tube that apparently I can't seem to grab. There we go. That goes between your extruder and the hot end. A deburring tool. Okay, this is a 3-flute deburring tool, right? And all you're going to do, put it down there, it'll self-center and do a couple 3 turns, right? All you're trying to do is get a slight chamfer in that, and then take a piece of filament and run it through both directions. And all you're trying to do is just get any little burr from your chamfering process. And what'll happen is now the very tip of this is a little bit bigger. And so that's going to be the tip that goes from your extruder down into your hot end. And that'll open up and give you a bigger target for your filament to go in. Well, so this is a tool for deburring holes. So I was building, still am, I guess, technically, a 2-seat all aluminum aircraft. So you drill holes, and then you have to deburr the edges of those holes. And so you use this to deburr all those holes. And then you're probably thinking of, we refer to these, I believe, as like Shavlik deburring tools, like this. Once again, this is a little more heavy duty than the typical like pen style, but this has different heads that I can swap out, and you use that to deburr like larger holes, like lightning holes, so larger holes in wing ribs and stuff. Yeah. But that's what you want to do, is add a little chamfer on it. And honestly, I chamfer both ends, because what I've found is when you go to do a retraction, you will get a little bulb at the end of the filament. And sometimes that'll get stuck as it leaves the throat or the nozzle, depending. Well, yeah, you got a V6, so you've got an all metal. So as it leaves that throat and goes up into the PTFE, it may have that little bulb, which may not let it go back through that PTFE, especially if you're using tight tolerance Capricorn tube. So put a chamfer on both ends. And when we cut this one, what I did was I put one end, got a flat edge, put one end into the top of the tool head and marked a line. Made sure it was all the way down in there, marked a line, measured that line. It was 20 millimeters. Then I did the same thing, put it up through the bottom of the extruder and bottomed it out, marked a line, and that was also 20 millimeters. So now I know I need a 40 millimeter length to go between the two. And I cut that length just a little bit proud of 40 millimeters. Okay? Chamfered both ends. And what that does is it gives me a little bit of a compression resistance fit. And because it's chamfered, it'll make that compression fit no big deal. But over time, if it does heat up in there, your PTFE will start to deteriorate. And that was one of the issues you had with the Prusa Minis, is the PTFE lined heatsink. That PTFE will start shrinking over repeated heating cycles as it wears. And so it's a consumable. You have to replace those things. So basically what you're doing is you're buying yourself a little bit of time by having just, it's not like 2-3 millimeters. It's just proud of 40 millimeter or what, however it's supposed to be. If it says 6 millimeters, cut it just a little bit proud of 6 millimeters. and it'll give you a good compression fit, and it should solve your filament issues. Okay. Oh, yeah, Buddha, I am in no way, shape, or form saying CSS is easy. I've got reference books over here to go figure that out. But yeah, it's yeah. But if you do those chamfers, it should give you a cleaner filament path going in and out. Okay. Oh no, trust me, I complain about work a lot myself. So on our, go switch the view again, go back over to the browser view. So a couple of things you want to start looking at first is, are you getting temperatures and are they about the same, right? So between the extruder and the heat bed, they're roughly the same. They're 22 point something, right around 22 degrees. So they're roughly the same. That means we're getting good readings. If they're really high or really low or not reporting at all, you've got a cable issue. You need to go solve the cable issue first. Okay? Your Raspberry Pi, if you set up your config to read the Raspberry Pi temp, then you're going to get whatever the temperature is that the board itself is sending you. And yes, as it stands right now, it's getting 45, 46, 47. Our fan is not running. So I've got my fan tied to the heat bed. So as soon as the heat bed kicks in, the fan comes on and it'll start blowing through the chassis. I did not want it running all the time. Okay, so those are some initial checks. The next thing you want to do on Clipper or in Marlin, and you can do this from the command line, you can do a query of your end stops. But I like coming over here to the machine tab and coming down, there's an end stops piece down here. You can click that button and it says, okay, all of our end stops are open. So one at a time, we're going to trigger the end stop. So I'm going to reach over here and trigger manually the X end stop. And then I'm going to say refresh. And it's now triggered. I'm going to go ahead and trigger the Y end stop, do a refresh. The X is now open, the Y is triggered. Now the Z end stop and the probe are one and the same, right? So all you need to do is take something metal and put it near your end stop, or not your end stop, but your PL sensor, and hit the refresh again. And you'll see that it's now triggered. Okay, move it away, no longer triggered. So that tells me that the end stops are working. So as I start to progress, when I go to start doing actual movements, I know that the end stops will trigger. Now I just need to make sure the next step, which is, are they moving in the right direction, right? Also here, you verified that you're getting a temperature reading. So one of the things that I would also tend to do back here on our main dashboard page is just put this at some temperature like 50, right? Or in this case, I'll go to 60 for the hot end. And there's a reason why. One, I want to see that it raises. The other thing I want to see is, because I've given it a temperature over 50, I want to make sure that the hot end fan is in fact turning, because my hot end fan is set to come on anytime the hot end is above 50 degrees Celsius, and once it drops below 50 degrees Celsius, it'll cut off. right? So when I said go to 60, this fan immediately started because I gave it a value above 50. If I go back and I turn it off, then it's going to start cooling that down. So I validated that the temperature came up to 60 and hung out around 60. It didn't like blow up and keep going. And now that I've turned it off, it's starting to cool down. And once it gets down to 50, which will be here in a couple of seconds, that should drop off. The other thing I can do while we're waiting, hold on a second so that I can show you this. We're at 52 and falling, 51. We dropped down to 50, and now 49, and the fan just kicked off. So that's what we're looking for. So we're making sure that how we set our firmware up is actually working. Okay. The next thing that we're going to do, switch back over here so you see my browser window, right? Is this still dropping down? Is we're going to do the same thing to our heat bed. We're going to tell our heat bed to heat up. And I'm not going to take it all the way up. I'm just going to go to like 40, right? So we see our heat bed power just went to 100%. Our heater's starting to heat up. And because our fan back here is tied to the heater, I'm just going to put my hand here and feel that the fan is working, and it is. I can also feel towards the front and feel air movement through the front now. And because that's moving, we may see the temperature drop down on the Raspberry Pi reading. It's not going to do it too much because that whole bottom is still open, so we're getting a lot of loss out the sides of the bottom of the printer, but we are getting some airflow through there, and you will see the temperature of the Pi fluctuate because of that. And once again, we're looking to see the heat bed heat up to around 40 and not like way overshoot and keep going, right? Because that would be indicative of a thermal runaway, and we want to shut down the heater real fast. Yeah, sometimes they do ask for more than what CSS can do. But the nice thing is the GUI for Clipper, it's all CSS, and you can go in and there are some community themes that you can use to add to Clipper that will have, I can actually go through and add on the left hand side here a picture of the stealth burner and things like that, so you can customize it. I can change the mainsail logo up by Blue Dragon and change that to the Voron symbol and so forth. So we put it at 40. It did overshoot a bit, but it's coming back. We see that the power is cycling on and off. It's going to drop it, and it's going to come back down into that good range. And we can feel it. It did actually heat up a little bit. And that's all we're really trying to do is just verify that the heater's working. Right? My wiring job is good. We didn't do anything bad. Okay? So now we've got those checked out. If any of those are wrong, then it's a matter of, okay, we need to go and verify our values. Maybe we don't have the right heater pins, so we need to go and validate our values. On Marlin, you have to open up VS Code. If you're using an old version of Marlin, it would be the Arduino IDE editor. But you would open up VS Code. You would you would change your values. You would compile it. You would burn it to the SD card. Then you have to flip over the printer, put the SD card back in, and reboot And it's a long, lengthy cycle every time you're having to make a change to fix something. Well, on Clipper, you have, under Machine tab, you've got various files here. Some of these are standard, some of these are created with other plugins, such as my screen breakout config, and that's for that little board that allows me to run my screen. And that's literally cut and paste the screen config and add some stuff into your printer config. Same thing with the Stealth Burner LEDs. You grab this file, upload it, then you make sure you have an include for in your printer config to include this file. You go in this file and you set the one pin, which is the pin for where you connected your LEDs at. And boom, all of a sudden all your LEDs work on your tool head. So that's the beauty of Clipper, is I've come in here and exclude object allows me to then set my slicer to define individual objects in the slice code. So if I'm doing a multi-part print and one of them starts to break loose, I can go into Clipper and say, stop this particular, stop printing this particular item, and it will skip over that item and redo and continue to print all the other things that are printing just fine. Right? And Marlin, I think, can do that with a plugin through Octoprint as well. So that's just that feature that's here. Display status and pause resume, that just allows you to have those features. Include main cell config is a requirement. Macros, you can embed your macros in your printer file, or what I do is have those as a separate file. That way my printer config is solely the configuration of the printer, and in my macros I actually set up all of my starting print commands. So my bed mesh, my homing sequence, my purge line are in the print start. So all I have to do in the slicer is say print start and send the filament, and so the extruder temp and the bed temp. The rest of it's done in a macro in Clipper. So if I need to change anything, I change it once, and that's in Clipper, not in the slicer. I never have to change that slicer setting again. Right, so that's a really cool thing. The include of the Stealth Burner, once again, that gets me my Stealth Burner LEDs. And I will show you a couple of different places where we can call and change those LEDs to show visual status of what it's doing. Same thing here with the screen breakout board. So if I need to change a motor direction, you'll see we've got our step pin called out and our dir pin. Dir is your direction pin. If the motor's moving in the wrong direction, all you have to do is right before that pin number, put an exclamation point. If you already have an exclamation point and you need to change the direction, you remove the exclamation point. So no more having to go and futz with the actual pins on the cable unless they're just not pinned correctly. Right. So if it's moving in the wrong direction, before, what you can do is physically rotate the jumper or switch the pins. Right here, all you have to do is put an exclamation point or a bang symbol or take one away, and you've now changed the direction. On your end stop pin here at line 77, you'll see the caret symbol in front of the PC0. What that's telling you is whether you have a pull-up resistor or not. So if your end stop is physically open, but it was showing as triggered, all I need to do is come and either put the caret in or take the caret symbol out, and it changes the reading. So once again, very simple. And then all I would do after I made a change is then come up and hit save and restart, and boom, it's restarting my firmware, and I am now back up and running, and I'm back to testing again. That's the advantage of Clipper over Marlin. Hey, Stephen Poole, thank you for joining us. Thank you for coming out and joining us this evening. So far we've talked about some of the wiring that I did on the printer to finish out the wiring and get everything going. And we're just going through what a normal new printer commissioning check set would be. And once again, this is basically for Vorons and Voron printers. And I didn't show you guys this. I'll actually pull this up here. So vorondesign.com. This is the Voron page. And if you go to the documentation, this walks you through various things like the build and talking about your wiring and different risks and stuff to wiring. Software installation, so this is how to get your Clipper, your mainsail, your Fluid or Octoprint front end set up. And then we get down into the software configuration. So this is building your printer.config file. And if you're building a straight Voron, then you can download the printer config file and you've got 90% of it already done, if not 100%. If you're doing a stock build, boom, you're ready to start going. Where I'm at now and walking you all through is in the initial startup checks here. And so we're just making sure that we can connect to the printer with the interface, which we did. And we've walked through and we're just checking basics, like we're getting readings on position, we're getting readings on temperature. We verified the heaters just by turning them on and off and making sure that we can heat them up and they just don't go haywire, right? And now we're going to go and do the stepper motor check. So on the stepper motor check, it's just a simple macro command here that you put in. And what that's going to do, and I'm going to come back and switch the camera view for us here so that you can see what this does when I actually run that command. So we're moving X, so our tool head should move left and right, but it's going to move by 1 millimeter and it's going to go positive then negative. Okay, so once again, we're watching the tool head. See it go right, left, right, left, right, left. And it's very subtle. It would be great if it was a couple of, like 2 or 3 millimeters or maybe 5 millimeters each way. But you're going to see that slight movement. And this gives you the initial feel that I'm getting movement out of the motors and whether it's moving in the right direction or not. Okay? We're going to do the same thing to the bed. And once again, it's the same macro command. And all we're doing is changing stepper underscore X to stepper underscore Y. And when we run that, our bed is going to move forward, back, forward, back, forward, back. And it does that 10 times under the macro so that you have plenty of time to look at and make sure that it's just moving forward and back. Forward and back. If it was moving back forward, remember back is moving the tool head forward in relation to the bed, which is the negative, which would mean that my motor is 1, operating correctly, but 2, it's operating in the reverse direction. So I could go in and change the direction in the firmware in the printer.cfg file for that stepper, and then just do a restart and I can verify that it's working again. So that's now the X and the Y. You would do the same thing again for the Z motor. And the Z should lift the tool head up, then down, which may be harder to see. Yeah, it looks like it's going to be harder to see. And in actuality, in order to move up and down, it takes both motors working at the same point. So it's probably going to be a little bit harder to see that one on camera. And then, of course, the extruder would be real hard to see because we got the fan shroud in place. If it's an open face extruder, you should be able to see the extruder moving. But what I'm going to do is just put some filament. Once again, this is an LGX. The nice thing with an LGX is all the way to the left, it's open. One click, and you're now set tension for rigid filament. So your PLA, ABS, anything else. Two clicks, and you're fully tensioned for your flexible filaments. Okay, we're going to go back to the left, and I should be able to take this and push it and just keep pushing until I've now hit the nozzle. So I'm going to put my finger there and pull it back out. That's how much filament I just put in there. Right? So I'm going to go ahead and I'm going to put it in. I'm not going to jam it down all the way. I'm just going to put it in a little bit and move that lever to the middle position, which means now I've got tension on it. And I just want to check and make sure it did get some bite on it. And the macro command on this one is a little bit different. Instead of saying like stepper E, I'm going to double check it. I believe it is, yeah, it's stepper underscore buzz space stepper equals extruder. Make sure I spelled everything correctly. And now it's going to be hard to see, but what we're going to look for is for it to pull the filament in and then out, in then out. And we might have to look at just the end here and see how it moves. Okay, so you see how it's moving to the left and then back to the right, left and back to the right. So that's telling you that it's moving in the right direction. Okay. Oh, I'm sitting here. I just did that. You guys couldn't even see it. Sorry about that. Let me run that again. Okay, so you see it moving. This is when it's pulling it in and then pushing it out. Once again, if it's going the opposite direction, it's pushing it out, then pulling it in, then you know that your motor direction is reversed, and you can go in and just change the direction. Now, I will tell you this. When I clip the cable and repin the cable to the smaller connector size, I put these wires in the exact direction as factory. Okay? The motor did the grind and then immediately shut down the printer and took a TMC error. So that told me something was wrong. I was trying to look, and initially what I found was one of my crimps had failed and the wire came out. So I had to partially disassemble the tool head and get the board off so that I could pull the connector out. And in doing so, I actually had two of the connectors, the crimp connectors, come loose. Because I was almost out of those small crimp connectors, I was able to get the wire back in the loose crimped connector, and I just dabbed a quick dab of solder on them, so they're now very solid, and all of these are good. They're pinning out good. the pairs were set A2, A2, A1, B1, B2, the right way that they should be. However, at the board, when I ohmed out the connectors at the board, rather than being pair and then pair, the outers were paired and the inners were paired. So I had to undo one of the outers, move the two over, and then add the other one so that it was pair. Go ahead and so I did have to change the pinout on this board, which means it's something in the wiring harness itself. The pairing was wrong, which it once again is normal. I almost expected to have that issue running the Creality wires with the stepper online motors, but I didn't. At most, I had a direction change on one of these. So I did have to ohm out, figure out which pole, which two wires match which pole, get them set up in the pin. Then I just had to double check, is it going in the right direction? So boom, now we have direction done. We validated all four of our motors are moving in the right direction. Now we're ready to do the next test, which is to actually go through and home one of the axes. So what we would do is, rather than home all, we're going to do one at a time, and we're going to home an X, then a Y, then a Z. So we did the stepper buzz, and we feel that they're moving in the right direction. Now we need to confirm that they're moving in the right direction, right? So our X end stop is on the right side of the tool head, which means I want to home in the positive direction, right? So when we set up our configuration, we actually came in for our stepper X. We've got our board pins, we've got our rotation distance and stuff set, we've got our micro steps, our end stop pin. Our end stop position is 220, so that's the full max position, right? Our minimum position is 0, our max position is 220, our homing speed set, and our homing positive direction is set to true, okay? Because we're homing to the right, which is the max direction. You'll notice on Y, which we're homing towards the back, that moves us to the front of the bed, which is the minimum direction. So we're homing in the, so homing positive direction is set to false. Okay? Position in stop is 0, min position 0, max position 220. Okay? So what I'm going to do is switch you back over to the camera view as I go in here and actually home the end stops in succession. So I'm going to home X, and we should see hex come over here. Now I would say when you first set this up, do not set it at 70 millimeters per second. Set it at like 10 or 20. It'll move a lot slower then, and you will have the opportunity to either hit the emergency stop or quickly reach over and tap the end stop button if it starts going the other direction. Right? Because you don't want it to hit and grind and go crazy. How are you doing tonight, Stephen Poole? What are you working on tonight? I know you've got a lot of prints you've been doing lately. What have you been working on print-wise? And now I'm going to hit the Y direction, so the bed should move back, which it is. And it's, once again, we would set these at lower values. Once we confirm everything, then we would go up and change the values of, in our printer config to go a little bit faster, just because we don't want to go slow all the time. And then I'm going to grab some metallic object, right? Because I don't really want to try and go off the bed. And I'm going to say home Z. Now when I home Z, because I've got a safe home routine set up, it's going to home X, it's going to home Y still, and then it's going to go to the center bed and start to home Z. So it raised up, home X, home Z, and now I'm going to put something metallic underneath it rather than let it go, because if it's not going to pick up something metallic, it could drive into the bed and mess up my bed, right? Okay, you just got some new filament. What filament did you get today, Stephen Poole? So we just use this to validate that we're good. One of the next steps that we'll do then is we're just going to say home all. Now we're going to make sure that everything works together as it's meant to. And we know it can pick up on a metal object. So we're going to go and check it against the bed. Okay. Now, when I go to do that, normally I still need to have a bed surface here. So either I'm going to have a crappy one that I've already damaged, or I would normally have a piece of paper. That way, if that nozzle is going to hit, it's going to hit something other than my PEI sheet. Now, this being a powder coated PEI isn't going to divot like, a good PEI sheet would. But I just want to be careful because I've set my depth on my on my probe, but that's the initial setting, I'll say, right? So the other thing, when we put on our bed, we want to make sure we crank these springs way down, because we don't want to have to raise them up to the point where now the springs aren't really compressed and the bed can shift a little bit more. I mean, we put the nicer springs on it. Let's work them. Now, what I found was at this stage, the next step is going to be to level your bed, right? Grat kit dual color purple green and purple orange, and 4 rolls from Sliceworks for a special project. What color rolls did you get from Sliceworks? And what kind of filament is it? Is it all PLA, Stephen Poole? I'm going to keep going because I do have a hard stop in about an hour, so I can get ready to run to the airport and get my kids. And we still have cake to eat, and we still want to get a print going. So what I did next is so a lot of people have some things in Marlin, and being an Ender 3 based printer, right? If I was running Marlin on this, I could still run the routine that like Chep has out there, Chuck Hullabach. I could run a routine that's all G code that just says go to these points and let me adjust, right? Clipper has something in there with a basic functionality. It's called bed _ screws _ adjust. And I'll show you, it's basically we set that G-code macro up, but it's called bed screws adjust. And when I click this, it's going to come over to where that screw location is, and I'm going to sit here and do the paper test, right? And okay, that's a little tight, but I am just going here and make my adjustment to get it where I want it, where it's running smooth and just starting to catch. And I'm using paper. I also have feeler gauges, but I was doing paper for this. The other thing I would say is when you're doing bed screws adjust, and I forgot to say this, so I'm going to abort this now and then go back over the web interface. One, I'll show you a couple of pieces in here. So I set mine up where I have all of my drivers to include all of my extruder settings. My initial rotation distance and stuff for this is set per Bondtech's website for the LGX Lite extruder. They have that information provided on their website for the extruder. So we don't have to worry about that. We can just get that right from them. So we start off with those generic figures. We set what sensor type. So this is what thermistor type that we have. If we're running like an exotic PT1000, we'd have to set that up as well. You have your pressure advanced settings, and you would have an initial set of PID settings in here, and they would be uncommented. These are currently commented out because I did go through a PID tuning exercise. That is one of the commissioning steps, is to run a PID tune on the hot end and the heat bed. And when you're done with that, which we'll run through one, it'll prompt you to save the config. And when it does that, it will comment out these, and they will add those values down at the bottom of the file. Same thing with the heater bed. We're telling it what pin activates the power to the heater bed, and then what type of sensor we have, and what that thermistor pin is, min and max temps. And this is an interesting setting. PWM cycle time. You want that setting on any of your heaters. So it's on the extruder and the heated bed. If you're running a chamber heater, which I will not tell you, that's on your own if you want to or not, and it's a heater, you want to set the PWM cycle time as well. This 0.0166 is for US people that are running on 60 hertz. If you're in Europe or Australia, the UK, or somewhere else like that, you will have a different setting because you guys are running on the 240 volt system versus the 110 volt, right? So just be aware of that. There is a setting, and what that does is that helps to keep your lights from flickering every time the heaters kick on, which will get very annoying if you have multiple printers running. This next setting here, section is what allows us to pull the temperature reading from the Raspberry Pi host computer. So all we're doing is actually calling the information that it displays. Then we have our controller fans, and this is where we're setting our heat break cooling fan, so the extruder fan, and we're setting a 50C limit. So if I tell it to heat up above 50C, it will kick automatically. It'll, even if it's down at 30, it will automatically kick on because it knows it's heating up to the target zone. As it's cooling down, once it drops below 50C, a little bit of lag, the fan will go off, and that will reduce noise and stuff from your fans. We also said that the heat, or the controller fan, this is the one that's connected into fan 0. That's the 6020 fan that's in the back that's providing cooling through the electronics bay. And you'll see that that is just set to the heater bed. So anytime we turn the heat bed on, that fan is going to kick on and start pushing air through the lower extremities of the printer. That way it's not always going, it prolongs the life of the heater, and since we're technically not printing at that point, it saves the life, and the controller board and the Pi should not be generating a lot of heat at that point. So there's really no need to have that fan running all the time. Okay. Then we get our probing section. This is where we set up the information for our probe, which is an inductive sensor. If we were using a BL Touch, we would have settings in here for the BL Touch. Then you have your homing override. This is also known as safe homing for your Z-axis. So that's where we tell it to go through in G28X, Y, and then go to a safe point and go to the homing process. We'll have our bed mesh parameters. And then here's this, we'll call it a macro for bed screws. And what this does is we've defined the points for the 4 spring locations in the screws. So it's not the actual corner, it's where those screws and springs are at. So it will go to that probe location and it'll run that macro. And then the bottom here is where your save configs are. So this is where you'll see the actual PID tuned values for the heater bed and the extruder. And then where I've set the Z offset for the probe. Okay. So once again, we're going to come into the dashboard and I want to show you what the command will look like. So it's bed screws plural _ adjust, because we're going to start an adjustment. And when I click that, it's going to come up with another screen. And it immediately goes down and it goes to the known position. And we can start adjusting at 0.04, which is the front left screw point, right? So I would adjust that. And what I would initially say is, whether you adjust it or not, say adjusted for the first round, right? So we'll click on adjusted. Now it says, okay, we've done the first point. We're going to go to the second point, okay? And we're going to check our paper. A little bit tight, so we'll adjust our tensioning screw so we get about the right amount of tension on the paper. Then we'll say, okay, we adjusted that, so we'll adjust it again. Now I am currently doing this cold. When you're doing it initially the first time, I would do it cold, right? I'm going to make a little bit of adjustments to these because you're probably going to have to make some big adjustments. And because you're making big adjustments, that's why I'm saying you're going to run through this a couple of times and you will run through this 4-point process. And as you adjust one screw, it is affecting the tension of the others, right? So you'll adjust these, you'll get them right. And once again, when you're doing this for the first time, you're probably going to have to make some large adjustments. And when I was doing this the first time, let me come back over here. I was getting close to the point where I could not feel the screw underneath the knob anymore, right? So what that tells me is there's too much of a gap. I don't have enough adjustment for the gap, which means I need to adjust my probe. So to do that, I have to take 4 screws, take the front off with the printer powered off because electrical connections. I'll power it off. I'll take the 4 screws and take the front off. Then I have to unplug the 2 connectors for the heater and the heat module pops off. Now I can get to the screws for the probe and I need to raise the probe up because I'm not getting down far enough before the probe activates. Therefore, I don't have enough adjustment to get it up and tight against the nozzle. So once again, I'll move my probe up so it'll trigger with the nozzle further down towards the bed, right? Reassemble everything. Then I will come in here and crank these knobs down on all four corners, let it do its probe, and start running the macro again. And then I will start getting these to where it's nice and tight. And then I should have enough adjustment point there. So I get all four done cold, right? And you'll go through that sequence a couple of times, because each time you're getting into a finer adjustment of the four knobs. So you get all four done, boom, you're good. Then you've accepted at all 4 points, and that macro will then end, right? There's no need to, I just accepted that one. So I'll have to go through, and once you've accepted at all 4 points, then the macro will just finish and say, okay, you're done with this macro, you've completed. I'll go ahead and say accept, boom. Since that was the last one, it's done, and it now is raised up. Now what I would do is set the extruder temp to like 170, 180, and the bed to 65. If I really wanted to, I could go up to full 215 and 60 or 65, whatever your normal printing temperatures are for the filament you most commonly use, which is normally a PLA. Because what I want to do is do it when everything's hot. So I will set the temps, let it get to a certain, let everything kind of sit and balance out and soak for a minute or two, then start running that macro. And that will let you get truly accurate in your bed perimeter corners. Then when you're done, you want to do a probe _ calibrate. Okay, so what I'll do first is I'll just rehome everything. And once again, we just went through, we would still be hot, right? I'm going to do this cold, but we'd still be hot. And I would do a probe _ calibrate. Okay, and you're going to do this. I'm just sitting here watching, I'm talking, and you're seeing my hands on the edge of the screen as I talk with my hands. So because we're using a probe, we're going to do this probe calibrate. And what it did is it just probed the bed, and it came up to a specific value, and you saw that the bed moved forward. So it probed where the probe is, and then it moved the bed forward by the offset that we've set between the probe and the nozzle. So the point where it probed is now right under the nozzle. And so now we have a new macro displayed that I'll show you all. Okay, and what I'm going to do is I've got various increments here that I can move it up or down. And I also, have increments that I can move it up or down. And I also have these big plus minuses. So what I'm going to do is, I'm way away from it now, so I need to start moving it down. So I'm going to start hitting this big minus, and you'll see those numbers drop by 0.2. So I'm just going to keep going, because I know that we're going to be a ways away, and you can look at it. And we're just waiting to see until our paper starts getting close. And now our paper is right on there. It's stuck now. So I'm going to raise it back up. Got one more. My paper's now loose. So I can go to the single down. I'm still loose. One more. I'm starting to get tight. What I'll do is I'll bounce up one, which was like a 0.25 measurement change. And now I can get down here and start getting really fine grained. So go 0.005. Check that out. Right. One more. That right there is good. So now it's got a new offset value. When I say accept, it's going to take the offset, which is 0.150, and apply that to whatever the last known offset was set to, and make that calculation. So I'm going to say accept, and you'll see here that the probe Z offset is now 0.550. The save config command will update. So I can either type in or cut and paste save command or save config, or I can come up to the top and hit the save config button. I'm going to do the same thing. It will save the config and then restart it. So it's restarting the firmware, and now it has that new setting. So if I come in to machine and look at the printer config and scroll all the way down to the bottom, it just updated this offset config setting right here. And that's what it saved. Okay. So now we'll just stop that. And like I said, because we're getting close to 7 o'clock and I have a hard stop in a half an hour, what I'm going to do is I'm just going to go ahead and preheat these. I don't have any preheat set up yet, so I'm just going to physically type in. I'm going to go to 215 and 65. Just let things start to get heated up. I have not actually run any filament through this nozzle yet. I've just done all the checks up to this point. So I am going to do a home all real fast. And then I'm just going to raise this up a bit, because I want it right in the middle. And we're actually going to load some filament. And I have come to like the K2 clips. Ran off a few of those to kill off the roll, and they actually work pretty darn well. And we grab some snips real fast so I can get a nice point on this. I'm going to go with this gray. This is a, which one is this? Anycubic gray PLA. Guess it helps if I switch screens for you. So we have an Anycubic gray PLA here that I'm going to load up. Where am I at here? I don't know why the browser window is still showing instead of the other camera, but I'll fix that. I'm just going to snip that off at an angle and try and straighten it just a bit, just to give me a better look. Once again, lever's all the way to the left. I'm going to insert it down in there. So I know it's got down a bit. Click one to the right. And that filament's now in there. And we are up at temp. And one of the things that we have on Clipper is a filament load and unload macro. And so that's what I'm going to do right now, is just click that filament load, and it's going to attempt to load that filament. I am feeling a lot of skipping. So where did we get to here? Yeah, we didn't make it in, so what I'm going to do is get all the way down where I know I'm going to be down in the hot end region. And it may simply just be that my filament load command is going too fast. So what I'm going to do is just do a manual extrude. I'm feeling a lot of skipping. So what we'll do is we'll go back here to our machine settings, printer config. So I'm getting a lot of skipping on my extruder motor. Under the TMC areas, you'll have your run current. And that might be my problem because I think I can run this all the way up to like 8 if I wanted to. I'm going to move it up just to 0.65. Now this is this 0.65 milliamps. And once again, I'm just going to save and restart. And when I save and restart, it's going to kill my heaters. This fan will come back on, but I will need to go ahead and just put my temps in again. Just bring my heaters back up. And I do have, I believe, while it's heating back up, I'm going to take another quick look in here. On the extruder section, you've got a min temp, a max temp. Make sure to set that appropriately. If you have a PTFE lined hot end, that should not be set above 245, okay? And then you have a minimum extrude temperature. This is a fail-safe so that you do not try and jam filament down through an unheated nozzle. If you're testing without filament, you're just doing initial tests, then by all means, drop that to 0 just so you can do extruder testing. Make sure it's moving in the right direction and so forth. But just make sure that you put that back, because that is something that'll help keep you from trying to extrude when it's cold. So we just turned up the current to that motor to see if we could get a little bit better. So we're trying to move 25 millimeters of filament at 5 millimeters per second, right? And retract pulls it out, extrude pushes it in, and you're getting the extruder temp is less than 170. Shouldn't be. Go ahead and just do a refresh. Yep. Okay, I'm not seeing any filament, and I'm still hearing some skipping. So once again, I'm just going to go back and move that voltage setting up a little bit. And I'm doing it slowly. I'm not going to like take it up crazy. And I want to say on the website it said anywhere from 5 to 8. So I'm now up at 0.75. Back to the dashboard. Set my temp again. I'm not feeling any skipping, and we've got filament coming out. So that's the good test that we're looking for right there. Okay. Now we set our extrusion multiplier, not really extrusion multiplier, sorry, our rotational distance. For marlin, that would be your God, I haven't used marlin in a while. Your E-steps, right? That's basically what we're going to try and do here. Marlin calls it E-steps. I can't remember what RepRap firmware calls it. And then we've got a different, we call it rotation distance in Clipper. And how's everybody doing? Am I giving you guys good information? Is it bad information? Am I boring everybody? What you would do to check and make sure it's set right is you would get a marker and a ruler, and what I always do for initial is I take this right at the top and I'm going to mark out 120. I'm going to go right to 120. Make me a mark. Okay. Now I can extrude 50 millimeters at a time. So I'm just going to come over here. I'm set to 50 and I'm going to say extrude. And extrude. So 50 times 2 is going to be 100. So what I will then come in and do once it's done, which it just finished, is now I'm going to come in here and I'm going to measure from the same point, which is right at the top, and see where I finished at. So I should be at 20 if I'm spot on, and I'm actually at 24, right? So I need to do a calculation again. And the calculation is always slightly different, so I want to make sure I'm doing it right. Sorry. Scrolling through the documentation real fast. Period calculation, E-steps. Okay. In a perfect world, you marked it at 120. It would measure 20. It wasn't. So the calculation would be your old configuration value times the actual extruded amount divided by the targeted extruded amount. So it was, we extruded, like math, not good. We extruded 96 and we wanted it at 100. So 96 divided by 100 is going to be 0.96. So we would go through and look at our config, and our rotation distance is currently set at 5.7. So public math, we're going to go and use our calculator on our phone. So 5.7 times 0.96, our new value should be 5.472. So we're going to come in here and change this to 5.472. Save and restart. So once again, we're going to restart, and we need to come back and get our temps back up to 15, 65. And we're going to go back and do it again because we have to verify. We'll make our mark at 120. And nothing. And we're just going to do the same thing again. We're going to extrude. Once again, still 50 at 5. We'll extrude.